going to do this first one again. So this is our going over the chi-squared and linear regression t-test things. So this number 1 is the, again, it's the 3 rows, 4 columns. So your degrees of freedom are going to be rows minus 1 times columns minus 1. Okay, next, number 2. The key here for number 2 is seeing that it says you are going to reject the null hypothesis. So the fact that you are rejecting the null hypothesis means that 0, so this rejecting means that 0 is not in the interval. Okay, so that's a key. That's one thing. Furthermore, if you are rejecting the null and you are finding the, going for the alternative is the slope is less than 0, that means it's a negative slope. So if it's a negative slope, then that means your intervals should be completely negative. So the ones, there actually were 2 of them that did not have 0 in them and were completely negative intervals, and that was A and C. All right, number 3. So the key here was number 3 is this language. There is evidence of a linear relationship. If there is evidence of a linear relationship, then you reject the null hypothesis. Okay? So there is evidence of a relationship means you rejected the null, which means your p-value is low. And it's at the 10% level, so that must mean that your p-value is less than 10%. So then you just look over there at your options, and A is the p-value that's less than 10%. Okay? Moving on, number 4. Okay, now keep in mind the wording. Number 4 says that you are going to interpret the interval. So interpret the interval, that's the key there. Because when you interpret the interval, the phrase for that is, I am 95% confident that the true slope of the relationship is between this and that. Whereas, okay, remember we talked about this last week. Confidence level. Confidence level is when you say 95% of all 95% confidence intervals contain the true slope of the relationship between this and that. Okay, so it wanted interval, so that's A. All right, now, starting with number 5, I highlighted this formula right here because it's going to be used probably 10 times or more throughout this little packet. Okay? Maybe just 10 times. Okay, so this is telling you that the standard deviation of the slope, that's S of B, is the slope divided by the t-score. Okay, S of B is B over T. It's a pain in the B over T. Okay, so therefore, when it tells you from this problem right here, it tells you straight away the test statistic is 7.07 and the slope is 1.51. Then I fill it into the formula here, and then I get the S of B value of 0.21. Okay? Now, number 6 is actually probably the most multi-stepped problem in this packet, so let's take a look at that. So, many things to consider here on this number 6. First, the regression analysis on the sample data set has 18 points. Having 18 points is going to give you the degrees of freedom. Degrees of freedom for a linear regression is n minus 2. So therefore the degrees of freedom we're going to use is 16. Okay, so that's one thing. Then it says the slope of the regression line is negative 3.91, so B is negative 3.91. And the standard error, that means the standard deviation of the slope, so S of B, is 0.84. So as you can see from this little piece, the formula that we're going to use quite a bit, I have got the 2 things. I have got the S of B and I have got the B. So I have 2 of those things. I can solve for the t-score. So I solve for that t-score and it has a value of negative 4.65. Okay? So that was the first step. I solved. I got a t-score of negative 4.65. Right now, you knowing that I have a negative 4.65 t-score, what do you think, what kind of p-value you're going to have? Probably pretty low, yeah. Close to 0, because that's a way far out t-score, okay? So even if you forgot how to TCDF to find the p-value, you could use your knowledge that that's a pretty far out t-score, so it's probably going to reject the null hypothesis. Okay, but here is how you get that p-value. Down there in the bottom right-hand corner, your p-value is going to find the lower tail. How did I know that my p-value is the lower tail, not the upper tail? Two reasons. Because more extreme on a negative t-score is lower. Furthermore, the alternative, yes, right here, the alternative is a less than, okay? So that's how I knew that I was dealing with the lower tail. Okay, thank you. All right, so I TCDF'd from negative 99 to negative 4.65, comma, 16 degrees of freedom, and that gave me a p-value of 0.0013, which is very small, like you suspected, and so therefore I'm going to reject. So I'm down to choice C or D. It will be rejected, and that means there is evidence of a negative linear relationship. Okay? The null hypothesis, okay, keep in mind, remember, if beta is 0, that means there's no linear relationship. So I'm rejecting that and concluding that there is a linear relationship, and it's negative. Okay, so that was really, I think, the most involved problem in this packet. I think the other ones were pretty straightforward. Okay, number 7. Here's another one, interpret the interval. So that's the wording for interval. We're 95 or 90% confident that for every one increase in the x, the predicted y will be increased between this much and this much. Okay? So remember our interpret the slope. For every one increase in the x, the predicted y, it does this. All right, so let's take a look here at this one. Here it asks what is the t-test statistic, the t-score. So, first of all, we see we have a two-tailed test. Oops. We have a two-tailed test, okay? And it says there is evidence of a linear relationship. So what does that mean to you if there's evidence of a linear relationship? What are you doing? We are rejecting the null. Okay, so this right here is telling me that we are rejecting HO. Oops. Rejecting HO. So my p-value is low. Okay. Furthermore, it says we reject it at the 10% level. That means that's my alpha. So I know I need to find a p-value less than 0.10. All right. Now, because of this alternative of beta is not equal to 0, that means I have two tails. And the two tails together should be less than 0.10. So what I could actually do is I actually just came over here to my answer choices, and I wanted to find the area in the tails. So let's just consider if you have a t-score of 0.09, where is that located on the curve? If you have a t-score, go ahead. Yes, very close to 0. So if you have a t-score of 0.09, you are pretty gosh darn close to 0. So what kind of p-value do you have? A huge p-value, okay? So I'm pretty sure it's not going to be A, and so on. So what I looked for is I just went ahead and I jumped to the largest t-score and I tried that one out. So I want you to think of what this would look like. Here's your 0, 1.83 is out here. So a tail for 1.83 is going to go more extreme, which will be out to the right. So I TCDF'd from 1.83 to 99 with 20 degrees of freedom because it's a sample size of 22. So that's my degrees of freedom of 20. That gave me a value of 0.04. Well, that is the p-value for one tail. But what is the p-value for two tails? 0.08. And is that less than 0.10? Yes. So there we go. That's my t-score. That works. Okay. Number 9. We've done one just like this before. You have a positive, completely positive interval. You reject the null, so 0 is not in it. So therefore, A is the interval that reaches those, meets that criteria. All right, number 10. Okay, so now for the next few problems, I want to remind you of the formula of how to do an interval for slope by hand. Okay, so watch this. If you are going to estimate slope, then you got to get the slope, the beta, or not beta, but the slope that you get in your sample, plus or minus the margin of error. And that is the critical value, that's t, times the standard deviation of the slope. Okay, keep in mind this section behind the plus minus is the what? The margin of error. Okay. Now, how do you get this critical value t star? Inverse t of 1 tail, comma, degrees of freedom. Well, guess what you need for degrees of freedom? Your sample size. So the sample size is necessary to determine the degrees of freedom so that you can get this margin of error. So that's why E is the answer. Because in order to get that critical value, you needed that degrees of freedom. Okay, now look at number 11. Again, this is going to use the confidence interval formula. Okay, B plus or minus T star times S of B. So when I take a look at this, let's look at the computer printout. Remember yesterday we reviewed how to look at a computer printout. Here is your slope, your beta. That is what all of these numbers, that's your sample slope, that's what all of these numbers are here. So that doesn't do anything for you. Therefore, what I'm interested in is what this is. That is your margin of error, which is this piece right here. Okay, this T star times the standard deviation of the slope. So what I did was I found T star was inverse T of 1 tail, comma, 8 degrees of freedom because it was a sample of size 10, times S of B. Where did I get this S of B? In the computer printout. Right here in the computer printout. Okay, so that's 0.2605. If I multiply those two numbers together, I get 0.601. And that's then why I know it's answer choice D. All right. 12 is A. I want to remind you, what is the large enough condition for chi-squareds? Large enough conditions for chi-squareds. Yeah, expected counts are greater than or equal to 5. Not sample size, not what you actually observe when you emptied out your M&Ms. But what's expected to happen happens to be greater than or equal to 5. So 2 is not true. A is the only one that's true on number 12. All right, moving on. Okay, number 13. Okay, number 1 says you reject at the 5% level. What are you going to look at to determine if you reject at the 5% level? What part of that computer printout gives you an indication to reject or fail to reject for the slope? The p-value of the what? Yep, per p-value of the slope. So I'm looking at this slope line, and I'm looking at this p-value of 0.019. And that's the p-value for the slope. So that is less, so we do reject it. So 1 is a true statement. Now beta, or number 2 here, number 2 says the slope, that's your B, is 3.345, and that's right here. Okay, so that is true also. 3 is not true because the standard error of the slope, that's the standard deviation of the slope. Recall where that's found? That's right here next to beta, so that is this number right here, 1.316. So that's the S of B. They have it written wrong in number 3, so 1 and 2 are the only ones that are true. Okay, number 14 is again another thing where you had to understand how to get the confidence interval by hand. It tells you this, 2.715 plus or minus 0.981. So I wrote that out here down here in the bottom section. Okay, so here is what they tell you. Now recall the margin of error is this part after the plus minus. So that means the margin of error is 0.91. And that is T star times S of B. So I came up here then, I took this little piece right here, and I wrote an equation with it. Okay, so I said 0.981 is equal to my critical value times S of B. I came up here and I set that in as an equation, and then I did my inverse T of 1 tail comma 23 degrees of freedom because of a sample size of 25, and then I could solve for S of B. All right. Now, let's see here. Okay, so number 15, it says which is the equation of the line, and when I first tried to do this problem, I was a little concerned because I was like, heck, I don't know how to find the y-intercept, but I do know how to find the slope. And then when I looked and I saw that all of the answer choices had a different slope, I was relieved because I thought, oh, I can know the answer by just finding the slope. So that's what I did. It gives you, the given information is a t-score and a standard deviation of the slope. So then, of course, we're going to use this thing right here. S of B equals B over T. I filled in the numbers and I solved for B. Okay, that then told me the answer was B. Number 15 is just definition of the expected counts. That's what hypothetically should happen if the null hypothesis is true. 17 is conditions for large enough. And you told me that a few minutes ago. Expected counts is at least 5, so greater than, and it's expected counts, not what is observed, what's expected to happen. Okay? All right, moving on. Okay, number 18 is D, is the answer choice for number 18, because it says which one is not possible. So that was my bad. I realized I had this one wrong last period. Okay, so let's think about this. When you look at this interval right here from negative 1.27 to positive 2.29, what do you think should draw your attention about that interval? There is a 0 in it. So if 0 is in the interval, then the slope could be 0. And if the slope could be 0, then there may not be a linear relationship. So I would pretty much, if I ran a test, I would expect to not reject the null hypothesis. So that's why D is false. Okay, D is a false statement. It says the HO is rejected, and it's not. Okay? I'm not going to go over 19 much, except for to say this is once again one of those ones where you simply put into the formula to solve for the missing item. Okay? There was quite a few of those guys. So that's why knowing that formula by, is important. All right, number 20, which of the following cannot be a chi-squared value? And that would be E, because you cannot have negative chi-squared values because they're squared. Okay, so that's all on that one. Okay, so now let's take a look at 21. I actually had this wrong the first time because I was back in the day when I was thinking that this same was leading me to think that it was homogeneity, but that was not right. Okay? The key is how many variables there are. So this is about grade distribution. That means your A's, B's, C's, and D's, and F's of 3 different professors. So think about how many variables that is. That's going to be a variable for your grades distribution and a variable for the professor that you have. So since there are 2 variables, then that's a chi-squared test of independence. Okay, I was asked last period what would the question be like if it was homogeneity, and I think it would be something like, remember a homogeneity pretty much has a yes and no? It would be like, are the professors giving A's at the same rate? Because the way you would organize that is you would have professors on one side, and then you would have the rate of A's and then the rate of not A's. So kind of yes or no top kind of idea. A, not A. Okay, so this is how it would have been written if it was a homogeneity one. All right, now number 22 and 23, we'll use the chi-squared chart because your calculator doesn't have an inverse chi-squared or a chi-squared CDF. So these are really, really simple if you know how to use the chart. And it's pretty straightforward. That's why I want to remind you of that. This is probably the only chart you'll use because you know how to do z-scores and t-scores on your calculator pretty well. But those ideas are not on the calculator for chi-squared. So let's take a look at number 22. Using a chi-squared goodness of fit, you had top 10 laundry detergents. That is how many categories you have, is 10 laundry detergents. Because they do say they have a sample size of 100. So what that begs the question of is, what is the degrees of freedom? And since degrees of freedom is categories minus 1, not n minus 1, then I knew it wasn't 99. It's 10 detergents minus 1, so degrees of freedom is 9. So that's an important thing to know. Furthermore, it says, you prove the point at the 0.01 level of significance. What is this saying if you prove the point at the 0.01 level of significance? It's statistically significant. You will reject the null hypothesis. So that's saying you will reject the null hypothesis at the 0.01 level. So the p-value you get should be less than 0.01. Okay? So let's go look at the chart. Let me review you on how to read the chi-squared chart. So if I pull that up here, then what I got here is on the left, you have your degrees of freedom. So that's why we needed to know we're talking 9 degrees of freedom. Okay? And then if I'm coming over here and I'm going to say, okay, so here's my 9 degrees of freedom, and I want to go to a p-value of 0.01. So that's this little one here. So that means that I am at 21.67 or more. Okay? 21.67 or higher will give me a p-value to reject the null hypothesis. So therefore, back to over here, that's why D then is the answer. A chi-squared number greater than 21.67. That's where that came from. Okay? 23 is similar in that it says you do a goodness of fit with 400 16-year-old students. They're getting their license and their birth month. That is your categories. See, in being 400 does not mean your degrees of freedom are 399. It's the 12 months that are the categories. So 12 minus 1 means your degrees of freedom are 11. And it says the chi-squared value is 23.5. So I have degrees of freedom is 11. I have, so right here, degrees of freedom is 11. I'm going to come over here to a chi-squared value of 23 point something and go up here and see what p-value is that. Well, that's a p-value in between 0.01 and 0.02. Okay? So those are two very pretty simple, straightforward things if you can recognize that you need to use the chart for those. And so that's why it's D. The p-value is in between 0.01 and 0.02. All right, almost done here. So 24, so actually just look at 25. 25 is A, 26 is E. Those are pretty straightforward ones on that. 25A, 26E. Let's come up here to 24. I think 24 actually has some errors in the problem itself because 24 says there are 400 birds. There's not 400. There's technically not even 4,000 birds. okay? Because if I took these observations right here and I added those up, they total to 3960. So this is just a messed up problem. But I went ahead and did it with the correct numbers. So here's how you would do it correctly. You would take the observed and put them into list 1. And so in this list 1 went your observed values of 220, 780, 730, and 2230. Okay. Then, so that was where the observed goes into list 1. Then you put the expected into list 2. So the expected that go into list 2 come from the percent, the ratio that you expect times the total in the sample. So recall this ratio here is 1 to 3 to 3 to 9, which is a total of 16 parts. So that means 1/16 of the 3,960 birds should be the first thing, and 3/16 of the 3,960 birds. So here's that ratio, 3/16 of it for the third category and 9/16 for the fourth category. How do I get that number 16, by the way? Add it up, 1 plus 3 plus 3 plus 9. Good. So if I add those up and I do a chi-squared test, so I went and I actually did a chi-squared goodness of fit test, then I got a chi-squared of 5.16 and a p-value of 0.16. That p-value is not going to let me reject the null hypothesis, so that is answer C. All right? So that's the end of that section. That's the last section that we have of our total review. So the last thing I'm going to go over with you today is that summary packet that I put online, and so I'm going to pull that up here and then we'll go over that.